In this video for matrices relating to VCE Further Mathematics, we're going to look at basic operations, including addition, subtraction, scalar multiplication, and multiplication of matrices. So firstly, addition and subtraction. When we're adding and subtracting matrices, they must be the same order, so they must be the same size. And the reason being, we're actually going to be adding or subtracting the elements that only appear in the corresponding positions. So if I'm to take the two matrices M and N that I have here, and if I wanted to do matrix M plus matrix N, what I'm actually doing is taking the elements in the corresponding positions and I'm going to add those together. So if I write that out, what I'm doing, I'll be doing 3 plus 8 in that spot for row 1, column 1. Row 1, column 2, I'll be doing 2 plus 11. Row 2, column 1, negative 1 plus 2. And row 2, column 2, 7 plus 12. And so that means I end up with a matrix that is 11, 13, 1, and 19. If I was to subtract, so let's do N minus M. So note I've changed the order and now I'm subtracting. And so this time, row 1, column 1, N is 8 minus row 1, column 1 of M, 3. So I'll end up with 5. And so I go through and repeat that for the remainder. So I've got 11 minus 2. I've got 2 minus negative 1, so I'm going to add. And 5 minus 7, negative 2. Now, of course, we might find that these are nice and quick and simple to do by hand, or we might find sometimes that the values are a little bit more challenging or that we are concerned about making errors with negative numbers. So we may choose to do this work in our calculator. If we are doing multiple operations with the same matrices, it's really useful to store those in your calculator. I'm going to show you how to do that now. Okay, so again, going into this little template button next to the 9, we get our options here. We have a 2 by 2 matrix, so we can pick that up from the pre-sized from there and enter in our numbers for the matrix M. So we had 3, 2, negative 1, and 7. And so if we are doing a number of operations, we can store that. And the way we do that, there's a little above the var button, it has STO with an arrow. So if we control var, it brings up that arrow. So it's storing, and we can tell the calculator, I want to store that as the letter M. And so now if I was to type in the letter M, it is stored, so it comes up bold, but then also when I hit enter, it recalls that same matrix. So let's do the same for N. Again, I've got a 2 by 2, and the values were 8, 11, 2, and 5. We'll store that one as the letter N. So now we can see there that if I type in the letters M and N, so if I wanted to do that calculation that I did before, matrix M plus matrix N, it will give me the answer there. So the next little operation that I may like to do is scalar multiplication. And scalar multiplication is when it's like I'm expanding a bracket. I have a factor on the outside of my matrix and I'm going to multiply that in to every element inside the matrix. So if I was going to, for example, do 4 times matrix M, what that actually means is I'm doing 4 times everything inside matrix M, which means I'm doing 4 times 3, 4 times 2, 4 times negative 1, and 4 times 7. So my answer matrix would actually be 12, 8, -4, and 28. Again, we can do this on our calculator quite simply, and that becomes really handy when we are doing things that are following a different set of rules. So maybe we are doing 2m minus n. Here, we're doing 2 times matrix m and then subtracting matrix n. And we can do that by hand, but it also might be quicker and easier to do with our calculator. So just quickly, if we wanted to do 4 times m, 4 times m, press enter, and that we get our answer there that we had by hand. And if we wanted to do something a bit longer, so again 2 times m minus n, press enter, and we get our final answer there. So it becomes an option for you. What is quicker? Is it entering and storing the matrices, or is it doing the calculations by hand? You need to make that choice and be familiar with using your calculator so that you can comfortably go between the two. So now to have a look at some exam style questions around this basic arithmetic that we've just looked at. Here we have 2 matrices. We're doing the first matrix plus 3 times the second, and they're asking what is it equal to. So this is just a matter of simply either multiplying that out, or I tend to look at just one single element. So if I think about this element here, that would be in row 1, column 1. So to get that value, BODMath still applies to matrices. So we need to, if we're thinking about BODMath, we're going to multiply before we add. So I'm going to do this scalar multiplication. 3 times 4 is 12, plus 4 means I'm getting 16 in that row 1, column 1 element. And so then if I look at the answers here, if I'm looking at that position, I actually only have one option that is giving me 16. So that I can say my answer is C. Now I can go ahead and calculate the whole thing just to be sure, or maybe do a second calculation if I wanted to double check, but sometimes it is a matter of just picking one piece and working that out. This second one is just a little bit different, but it's the same idea. So here I've got a matrix equation, but instead of a matrix here, W, I've got just a space filler. Okay, I need to work out what must that matrix be. So firstly, because I'm being told I can add it, and it is equal to what's on the right-hand side, W must be a 2 by 2 matrix. So I do know I'm going to have something that is 2 rows and 2 columns. If I think about what I do know on the left-hand side, here I can say, well, let's multiply this out. So 2 times 3 is 6, times 0 is 0, 2 times 4 is 8, and 2 times -1, -2. And I know when I add this mystery missing matrix on, it's going to equal 6270. So let's look at row 1, column 1, and decide what element must be here. If I've got to go from 6 plus something still equals 6, then it must be a 0 in that first row 1, column 1 element, which means I can eliminate D and E because they have 12, and that would give me an incorrect answer. Now let's look at the second element. So I've got 0 plus something equals 2. So in that case, this must be a 2. And so out of my options A, B, and C, we've got A and B are giving me possible correct answers. I can eliminate C. If I now look at option for row 2, column 1, I've got 8 plus something equals 7. So that actually must be -1. I need to take 1 off. And if I look here in my answers, B is the only one that gives me that option. So A can be eliminated and our answer is B. We're now going to look at multiplying matrices. So whilst you will always have a calculator available to you, there is some benefit in being able to multiply matrices or at least check components of a question by hand. And we'll look at a couple of specific examples in a moment where knowing how to apply the rule or the method for multiplying is the only way to be able to answer the question. So firstly, when we're multiplying matrices, unlike addition and subtraction, they don't have to be the same size, the matrices that we're working with, the order, but they do have to have a special property. And that is that the number of columns in the first matrix must be the same as the number of rows in the second matrix. So if we consider here, matrix A has an order or a size of m times n. Matrix B having an order or a size of n times p. Then the columns in matrix A must be the same as the rows in matrix B. So, for example, if A was a 2 by 3 matrix, B was a 3 by 1 matrix, then yes, we can multiply. Okay? It is also referred to as being defined. So the product would be defined. Another neat little trick is that the two outside values, so the rows of the first matrix and the columns of the second matrix, tell you the size of the result. So the result would be a 2 by 1 matrix in this case. So that can come in really handy when you're looking to try and work out, well, what type of answer do I need further on down the track when we're looking at applications. So an example here where you don't have to do any actual multiplying but just checking whether it's possible is of the 4 matrices, W, X, Y, and Z, which of the following products is not defined? So which one won't work? So firstly, we need to think about the order of these matrices. So W is a 3 by 1, X is a 2 by 3, Y is a 1 by 2, and Z is a 3 by 3. So then when we look at our options here, W times X. So W is a 3 by 1 matrix, and X is a 2 by 3. Can we do that multiplication? Well, actually we cannot, because the columns in matrix W are not equal to the rows in matrix A. So we think already A is our answer here, but let's check the remaining just to be sure. So X is a 2 by 3, W is a 3 by 1, and yes, we can do that multiplication because those values are the same. Y is a 1 by 2, X 2 by 3, and again, yes, 2 columns, 2 rows. Z is a 3 by 3, W a 3 by 1, so again, yes, columns and rows. And finally, W is a 3 by 1, Y is a 1 by 2, and so again, yes, rows and columns. So that gives me A as my answer, being not defined. So now we come to how we actually multiply. We use a method called the run and dive method. And what that means is that as we are working across, we are running across the row of the first matrix, and at the same time, we are diving down the column of the second matrix. Once you get the pattern, it's quite straightforward, but it can be a little bit confusing to begin with. you will never ever be expected to multiply anything bigger than a 2 by 2 with another 2 by 2 by hand. You will always have your calculator to assist you. But you do need to at times know how you calculated or how you could find one of the final elements. And so we've given you this breakdown here. If we have matrix A and its elements labelled with their row and column reference, and matrix B also labelled row and column reference, then our product matrix, matrix C, is given as we're running across this row A. So the first value would be A in row 1, column 1, times B in row 1, column 1. And then we would continue on and add that to moving across the row. So A, row 1, column 2, with B moving down the column, row 2, column 1. And you can see that calculation written out here in that first element. So when I'm working with row 1 in matrix A, column 1 in matrix B, it's every element in that first row, every element in that first column to give me the final result that goes in that space in the final answer, row 1, column 1. So then when I'm dealing with row 2, column 1, again, row 2, column 1, everything is used there to get that final answer. So it can be a little messy. It is worth persisting and working through how we do that. So let's look at an example now. Okay, so here we have our two matrices A and B, and we want to do A times B. So let's firstly set up, and we're going to do this, take up a lot of space so that we can work through it. We're going to firstly work with row 1, column 1. And so the first calculation is 1 times 4. So both of the elements, row 1, column 1. Then I'm going to move across, so using the 3, and I add this, times, move down the 5. So you can see that as I've moved across the row, I've also moved down the column. If we work out that little mini calculation, I've got 1 times 4 is 4, plus 3 times 5, 15. So 4 plus 15 is 19. Will give me my result there. So now let's look at still row 1, but let's do row 1, column 2. So now I'm going to be working in this space here. Okay, so again starting 1 times 0. So we're starting at the top of, or the start of that row and the top of the column. And then as we move across the row, 3, we also move down the column. So 3 times 1. And so there we've got 1 times 0 is 0, plus 3 times 1 is 3. So our result will be 3. Moving on now to row 2. So let's go row 2, column 1. Again, starting at the beginning of the row, we now have 2. The top of the column, 4. So 2 times 4. Plus, as we move across, 0 and down 5. So 0 times 5. So here we have 2 times 4 is 8, plus 0 times 5, 0. So 8 is our result. And finally, row 2, column 2. So we're now working in this space here. Start of the row, 2. Top of the column, 0. So 2 times 0. Plus, we move across, 0 and down, 1. 0 times 1. 2 times 0 is 0. Plus 0 times 1, 0, gives me 0. What you might notice, if we're just to look at the working space here, is that the number 4 is repeated, the number 5 is repeated. As you work across, it's always 1 times something, 3 times something, 1 times something, 3 times something. You should notice there is a little bit of repetition, but you'll only really see that if you're doing bigger multiplications. But as I said, likely that you will just get a 2 by 2 that you would need to do by hand. Okay, everything else, the time it takes you to do that, it is more time efficient to do these multiplications using your calculator. So the one type of question where you wouldn't use your calculator, that you do need to understand this run and dive method, is one like this. So here we're given matrix A, which we can see is that 4 by 2 matrix. Matrix B is a 2 by 4 matrix. And they're telling us that matrix Q equals A times B. The element in row I, column J of matrix Q is given as Qij. So there's that same notation that we've seen before, and they use it quite a lot. The element Q41 is determined by what calculation? So know here that they're giving us a row and a column reference. And if you remember from the previous example, to get our product answer there, we are going to work with the row from the first matrix, so row 4, and the column from the second matrix, column 1. And so just by isolating those two, we can say, well, the multiplication that we would have done to get the answer, starting at the start of row 4, so we've got the number 4 times the start of column 1, 2. We move across 5, and at the same time move down times 4. So that's our calculation that we would do to get the element that is in that row 4 column 1 value. And so when we look at our options here, we can see that matches E as our answer there. So this next example is one that looks really simple on the surface, but is actually quite a challenging question. So here we have the matrix product. We're given our two matrices and saying that is equal to, and we've got lots of options there. So the first thing I would check when I'm looking at a question like this is, well, is the product defined? And then secondly, what would the answer look like? So remember, if we check our rows and columns, so the first matrix here is a 1 by 3. It's got 1 row and 3 columns. And we're multiplying that by a 3 by 1 matrix. So firstly, yes, it's defined because the middle values here, the rows and the columns are equal. What it means is our answer will be a 1 by 1 matrix. Good news, except the answer, the only 1 by 1 matrix that is here, is actually not the correct answer. So this is a tricky question because we could be fooled into thinking that A must be the answer because it's the only one in the right size or the right order. So instead of giving us an actual product, what they have done is given us an equal or an equivalent matrix calculation. So we have to check which one would actually give us the same answer. And so a way of doing that using our calculator is actually just to key in each option. So let's have a look at that now. So I've just put that matrix calculation in, and if we were to actually find out what that equals, it gives us 40. So yes, it is a 1 by 1, and the value, the element, is 40. So what we need is an equivalent out of those options. And we already know A can be eliminated, but out of those options, which one gives us an equivalent answer? If we think about it too, option B wasn't the correct size. It was a column matrix, and we wouldn't end up with that. So we're left with 3 options, C, D, and E. Each of them look like they've had a scalar taken out of the calculation at some point. And so one way of checking, if I did want to guess and check each one, would be to actually take my original entry. If I then press enter and then put in the next matrices. So option C had 4 times a row matrix, which had 1 row, 3 columns, and the values were 1, 2, 0, then that was multiplied by the column matrix, which had 3 rows, 1 column, and the numbers 1, 12, and 8. Now, when I press enter, it will actually tell me whether this is true or false. So here, it's telling me, no, false. They do not equal each other. So I can safely say that C is not my answer. So I could go through and check option D and option E as well, and check which one actually gives me the correct outcome. Alternatively, I could do a quick little calculation here to see if my result ends up at 40. So for D, I could make all of that, so times everything in that first matrix by 2. And then as I'm working across my row, I'm coming down the column. So when I'm multiplying that, I would have 4 times 2, so 8, 2 times 6, 12, and 0 times 4, 0. So that would give me 20 as a result. And we've already said no, it equals 40, so it's not D. A final little quick check of E. So again, let's multiply in that scalar. So 8, 4, 0. And we're multiplying that by 264 again. So 8 times 2, 16. 4 times 6, 24. 0 times 4, 0. And that gives me 40, which is actually what I want. So my answer, the correct answer is E. This final example is one that I tend to say looks really complicated, but with the right strategy can actually not be too inaccessible. So don't be put off by all the letters. Let's just work it through and we'll talk about a way of approaching it. So matrix A is an n times n matrix where n is greater than 1. So that's just basically saying it's a square matrix where it has more than 1 row and column. Matrix R is a row matrix, so it has single row, multiple columns. Matrix C is a column matrix, so it has 1 column but multiple rows. Which one of the products could result in a 1 by 1 matrix? Okay, so to make life easy, I am going to pick a size for matrix A. I'm going to say that A is a 4 by 4 matrix, so its order is 4 by 4. I'm going to say that R is a row matrix, so it has 1 row, but it has 4 columns. And I'm going to say that C, as a column matrix, has 4 rows, 1 column. So the reason I've elected to make these rows and columns match A is so that I know that I'm going to end up with something that can work, rather than a whole heap of options that don't work. So now we just need to work out what is defined, and then once we've identified if it's defined, what would the answer look like? And we go back to that idea that if we do have a defined product, the answer or the size of the answer will be the outermost values. So the row right at the beginning and the column right at the end. So what do I mean by that? If we look at answer option A, where I have A times C times R. So A is a 4 by 4. C, I've said, is a 4 by 1. And R is a 1 by 4. So firstly, the middle numbers, 4 and 4, that works. 1 and 1, that works. Our answer, however, will be, it'll result in a 4 by 4 matrix. So whilst it's defined, it actually doesn't fit what we want as our result. So A is not our answer. So let's check the next one. Again, starting with A is a 4 by 4, R is a 1 by 4, and C is a 4 by 1. Now in this case, we don't have a defined matrix. Those first two can't be multiplied. So no result, no defined product. C, so this time we're starting with matrix C is a 4 by 1. A is a 4 by 4. And R is a 1 by 4. So I already knew right at the beginning I wasn't going to get an answer because I didn't have a 1 to begin with. But also we can see we don't have a defined matrix in either of those multiplications. So C is not our answer. D, R is a 1 by 4. This is looking promising. I've got a 1 to begin with. A is a 4 by 4. And C is a 4 by 1. I have rows and columns match. Rows and columns match. So we are defined. So therefore our answer will be our outermost, so a 1 by 1 matrix. And that meets the criteria. Let's just double check to make sure we haven't made an error or ended up with 2 correct answers. R is a 1 by 4. C is a 4 by 1. And A is a 4 by 4. So here, matching, but no. So we can't define that, which leaves us with D, as our only answer there, giving us a 1 by 1 matrix. So from the outset, seemed a really challenging question and would have been one of the final questions in the paper in this section. But knowing that you can apply some numbers and play with what might come out means that you might be able to find a strategy to help you answer that successfully. Okay, that's it for this section. In the next video, we'll look at some applications of multiplication.